We are now starting with the solution for homework 1, question 3. So this question can be solved in multiple ways, but the most important thing is to understand what the questioner is asking you to do. So let's quickly go through the question and try to understand how the dice game works, okay? So you and your friend are playing a game of dice on a 6-sided dice, so that's a regular dice. Each of you rolls the dice and the numbers you roll are subtracted from one another. You play 3 rounds of this game. The first and second roll in each round are labeled with the variables R1, 1, round 1, roll 1, R1, 2, round 1, roll 2, R2, 1, round 2, roll 1, and so on. To calculate the number, the second roll is subtracted from the first roll in each round where you roll first and your friend rolls second. Alright, so we have you and your friend, and this is round 1, round 2, and round 3. So going by the naming convention, you are the one who's always going to be rolling first and your friend is the one who's always going to be rolling second. For round 1, we're going to have R1 and then underscore 1 would mean you, R1 underscore 2 would mean your friend. For round 2, R2 underscore 1 would mean you, R2 underscore 2 would mean your friend, and it's the same for round 3. So this is the structure of the different rounds, this is the players, and these are how each of these roles are named. Alright? To calculate the number, the second roll is subtracted from the first roll. So to gain points, the second roll, which is R1, which is rolled by your friend, is subtracted from the first, which is R1 always, and that is the round that you played. Alright? You get a point if the calculated number is positive, including 0, and your friend gets a point if the number is negative. Alright, so this is positive, comma 0. Okay, so if the number is positive, comma 0, you're the winner, and if the number is negative, your friend is the winner. So the premise of the question is basically your roll should have a greater number than your friend's roll. That's the only way this solution, which is num, is going to be positive, right? All right. And now we have calculate 3 variables LG1, LG2, LG3 of the logical type to test if you win a point for each of these 3 rounds. Positive number is calculated. So we're now trying to focus on you winning the game. Okay? And also create a variable called total points to calculate how many total points you've earned after 3 rounds. So that is going to come at the end. Okay. So let's get started on the question. I'm going to minimize this and we have our MATLAB window. I'm going to save the file first. Here we have homework 1, question 3. Dice game. Alright, so first of all, let me copy the script that has already been given to us. This is it. If you notice carefully, we've been given all the values for the rules of the dice for round 1, roll 1, round 1, roll 2, round 2, roll 1, round 2, roll 2. Alright, and the same for round 3. Okay, so the first thing I need to do here is calculate the points for each round. So the first thing is LG1. And how would I go about doing this? So we have multiple ways to solve the problem. If you remember from the notes, we have learned about the sine function. So what does the sine function do? The sine function gives me positive 1 if my number is greater than 0. It gives me 0 if my number is equal to 0. And it gives me a negative 1 if my value is anything less than 0, right? And in this particular situation, what did we learn? So if the subtraction result is positive or 0, you are the winner. And if it's negative, your friend is the winner. And LG1 determines if you have 1. So one way to do this is to check the sign of the subtraction. So round 1, roll 1 minus round 1, roll 2. So this is the number for the first round, and I need to check if this is not equal to -1, because that would mean it's either 0 or +1, right? So this is not equal to -1, which means your friend is not winning. All right, and this would give me, the answer of this would be a logical value. So it would be either 1 or 0, because it would calculate the sign of the number. If it was +1, that would mean it's not equal to -1 and you win, right? So that would give you a logical 1. If it was equal to 0, which still means that you are winning, 0 is not equal to -1. So the answer of LG1 would be 1, again, which is logical 1, and you'd be winning. And if the sign of this was negative, in which case your friend should win, sign would give you a -1, which would be equal to -1, and the value for LG1 would be 0, or a logical false. All right. In a very similar way, I'm going to write the same code for round 2 and round 3. So here it would be R21 minus R22 is not equal to -1, and LG3 equals sign, oh, I missed this, R31 minus R32 not equal to -1. All right, so this is one of the ways to do this particular question. Now, we did receive a lot of questions about if we needed to use the absolute function, or if it was okay if we did not use the absolute function. So you can totally do this sum without using the absolute function, but there is a way to use the absolute function. And how would I go about doing that? So if I were to write, so what is, I'm going to keep this as a comment, using ABS function. All right, HW01 equals. And I'm going to comment all of these out because I've already calculated my LG1, 2, 3 values, and I don't want to repeat it, but it's a good thing to know how to solve this question using other methods. So I would say ABS of round 1, roll 1 minus round 1, roll 2 equal round 1, roll 1 minus 2. Okay, so how would this particular code work? This is the number that is the answer for my, to check if like I got the points or not, right? So if the absolute value of this particular number matches the actual subtraction, that means the actual subtraction is a positive value, because absolute values always turn all the variables within the absolute function into a positive number. So if the absolute value and the regular value matches, that means the regular value was also positive, which means you won the point. And if it was 0, that also would give you true for the double equal to equality sign, right? However, if the result of this particular subtraction was a negative number, which means your friend won, the absolute function would return a positive value, whereas this particular expression would give a negative value, which would not be equal to each other, and therefore the answer for logical 1 would be a false, thereby denoting that your friend won. Okay, so that's how I'm also going to write LG2 and LG3. So R1, sorry, this is round 2, minus R2 to double equals right. For the third one, I am just going to copy the same thing because it's a really similar code, and then I'm going to edit it. So I'm going to say LG3, I'm going to say round 3, round 3, 3, and 3. All right. Another way to write this same expression in a slightly clearer way is ABS function would be to say val or num. Let's say num. Num is my answer for R1 minus R2. So I would say num1 equals, this is the num for round 1, okay? So R1 1 minus R1 2. And then I would use the absolute function to check if this value is positive. So I would say ABS num1 equal to num1. And in a similar way, okay, I'm going to comment these out because I've already written the code for LG1, right? And that would give me an error if I have two LG1s. Okay. So in the similar way, I would also write num2 for round 2. So R2 1 minus R2 2 would be num2, and then LG2 would become ABS double equals num2. So as you can see, there's multiple ways of writing this particular question. You can also just check if this particular subtraction result, which is also like num1, num2, is greater than 0, greater than or equal to 0, in which case you would have 1. And if it's less than equal to 0, then your friend would have 1. All right. So it's up to you how you want to solve this question, as long as you understand the concept of the question and understand what we are comparing in this. All right. Okay. So now I'm going to run this problem. It runs properly. There's no errors. I can see all my values in the workspace. Oh, wait, I think I forgot one part of the question. So also create a variable called total points to calculate how many points you have earned after these 3 rounds. So this is very important. I'm sorry, I totally missed that part. Okay. It is always a good option to take a look at your workspace and then compare it with the assessments. So when I'm looking at my workspace, I see I have my LG1, I have my LG2, I have my LG3. However, I am missing my total points, which means I am still missing something from my code, okay? So what I need to do is calculate my total points. So total points. All right, and how would I do this? I'm first gonna write my variable in which I'm gonna store my answers. So total points equals. All right, so these values, the LG1, LG2, LG3, tells me how many points I'm getting. So if I get a point, it's going to be, the value is going to be 1. And if I don't get a point, the logical value is going to be 0. Because in each round, irrespective of how much the difference is, you can score only 1 point, right? The number is just used to determine if you are winning or your friend is winning. So since I can only gain 1 point per round, I can use these logical values to calculate my total points. And how would I do that? I would add all 3 of these logical values. I would say LG1, LG2 plus LG3. And this would work. Why? Because LG1 would be 1 if I win. Therefore, it would add 1 to total points. However, if I lost, then LG1 would be 0 and it would not add anything to total points. And another thing to keep in mind is these logical values would get typecasted. So this is a type conversion. MATLAB will automatically convert my logical 1s and 0s to double 1s and 0s since I am performing an arithmetic operation on all of them. I am using the plus operator. All right. Okay, I'm going to run this solution again. Okay, it runs again without any errors. And when I check my workspace, I see I have my LG1. Okay, let's compare it with the assessment. I have my LG1, LG2, LG3, and total points. All right, perfect. So I'm going to copy this whole code. Copy. And I'm going to go here and paste it. Oops, I made a mistake. What did I do? I copied the whole code and I included all of this. And this initial part is already included in the snippet. So I need to remember not to do that. So I'm going to copy the rest of this here. All right. Now I'm going to run my script and submit. Oh, I made a mistake. LG1, LG2, LG3, I completely used LG in underscore. I need to correct that. All right. My mistake. So I'm gonna edit all of these numbers quickly. I'm sorry. I'm gonna change all of this. You don't need to change the comments, but I'm just doing it for the sake of accuracy. And if I revisit the question later, then it should be right. So I'm gonna change all of this. Okay. And this should run perfectly now. Oops, my mistake. All right. A moment of truth. All right. All tests passed and we're done with this question. Welcome back everyone. We are now starting with the solution for homework 1 problem 4, which is the arithmetic problem. Before we start, I would like to draw your attention to the fact that this question is really similar to a question you've done in your tutorials before. It's module 1, question 5. So if you would like to take a look at that problem before you solve this, feel free to do so. Another thing I would like to draw your attention to before we start solving this problem is unit conversions. So I'm going to give you a quick review of unit conversions. Okay, if you remember from your previous chemistry lectures, so I here have the two values that are given in the question. So 1 feet equals 0.3048 meters and 1 pounds equals to 0.45 kgs. All right. And I have just divided this feet by like this 0.3048 meters by feet and this by pounds to get my conversion factor. All right. So suppose I have a question where I need to convert, say 2 feet and I need this in meters. What am I going to do? I'm going to multiply 2 feet and I'm going to multiply this by 0.3048 meters divided by 1 feet, correct? So this way my feet units get cancelled and I end up with 2 times 0.3048, which is 0.60, I think, 96, yes. And the unit for this is meters, so meters. And I've successfully converted my 2 feet to meters, right? Now suppose I need to convert 2 pounds per feet cube. Sorry. How would I do this? And I need this to be converted to kgs per meter cube. All right. So I'm going to write my 2 pounds per feet cube. I'm going to multiply this by this particular conversion factor because first I'm focusing on converting the pounds to kgs. All right. So I'm going to write 0.45 kgs divided by 1 pound. I have successfully converted my pounds to kgs because these pound values would get cancelled, right? Now I need to think of a way to convert my feet cube to meter cube. So let's think about it. Let's multiply this by 1 over 0.48. So 0.3048. All right, and the unit for this is meter per feet. Is this enough? Is this enough to convert my feet cube to meter cube? No, because if I try to cancel this, it's going to only cancel 1 feet units, right? But here I have a feet cube. What am I going to do? I'm going to take the whole cube of this value. All right, so then my pounds will get cancelled. My feet cube are going to get cancelled. And I'm going to end up with, so this is going to be 2 times 0.45 divided by 0.3048. The whole cube. So that is 31.78. And the unit for this would be, in my numerator I have kgs, and in my denominator I have meter cubed. Okay, so these are two of the concepts that we're going to use to solve this problem today. All right, let us start then. I have my MATLAB Grader open to this learner preview, and I also have my MATLAB software. So the first thing I'm going to do is save this in a way that I can revisit this later. So homework 1, question 4, sorry. And I'm going to write arithmetic. All right, let's read the question. Kasturi has been given the values for acceleration due to gravity, fluid height, and fluid density for an unknown fluid in the imperial system. She needs to find the total fluid pressure at the given height in the tank in the metric system. She has also been provided with the value for air pressure at the top in metric units, which doesn't require unit conversion. Okay, so I'm going to go to the script and firstly copy everything that is given here. And I'm going to paste it on my MATLAB. Okay, moving on, looking at the answer in question in part A. Oh, before that, so if you remember, before we did any of these calculations, we had our unit conversion factors laid out, right? So I'm going to do the same in this question. What I'm going to do is define two variables, feet to meter, which is 0.3048. This is the conversion factor for converting anything in feet to meters. And I'm going to define another thing, which is pounds to kg. This is for anything that is in pounds, and I need to convert it to kgs. Okay, looking at part A. Convert the value of gi to meter per second square and assign the value to gm. The initial value of gi is in feet per second square. So I am going to write gm here and write the equal to sign, because gm is the variable into which I need to assign my value, right? And then I'm going to write the expression. So what do I need to do here? I need to convert feet to meter. Do I need to worry about the second square? No, because the second square remains the same in feet per second square and meter per second square. So there is no unit conversion taking place for the second square part of the equation. So I simply need to convert the numerator from feet to meters. And how do I do that? I multiply gi by the conversion factor, feet to meters, which is 0.3048. So I'm just going to use this same variable, so feet to meter. All right, that's all for part A. For part B, so convert the value of hi to meters and assign the value to hm. Again, hi is in feet and I need to convert it into meters. What am I going to do? Use the feet to meter conversion factor. So I'm going to write hm equals hi times feet to meter. All right, and I'm done with part B too. Coming to part C. So here I need to assign a value to the variable called rho m. So I'm going to write that down. I'm going to write rho m and put the equal to sign. What is the value of rho I? Rho I is in pounds per feet cube. So if you remember, what we did here was we first multiplied it by the conversion factor to convert pounds to kgs, which was 0.45, and then we divided it by the factor which is used to convert feet to meters, and we cubed it because the denominator is a feet cube and I need the answer in per meter cube, right? So that's the exact same thing we're going to do here too. So we're going to write rho I, then I'm going to use the multiply sign, and then I'm going to say pounds to kgs because I need my numerator to change from pounds to kgs, and then I'm going to divide by feet to meters, and I'm going to write Q. All right. And that's it for my C part. Moving on to the part D. Find fluid pressure at height HM and assign the value to P1M. Okay, so I need to assign the value to P1M. I'm going to write P1M right here. What is the value? What is the formula for P1? So it's been given here under notes. So P1 equals G times H times rho. If you look carefully, P1, the answer should be reported in kilograms per meter times second square, right? So P1M is in metric units. You need to make sure that all the variables you're multiplying are in the same unit. So to get P1, I'm going to multiply GM times HM times rho M. All right. All three of them are in metric units and my answer is also in metric units. And that is exactly what the question asks. For part E, I'm going to say P. So I need to assign the value to PM. And what is the formula for P? So P, the formula for P is P naught plus G times H times rho. So for PM, this part is the same as P1M. And P naught M is given to us in the question. And this is already given to us in the metric system. So I do not need to convert this. So here I'm simply going to write P naught M plus P1M from part D. This should be caps lock, sorry. All right, another way I could have done this would have been PM equals P0M plus, and in brackets, I would have said GM times HM times rho M. The reason I'm not doing it because I already have performed that calculation and I already have that stored in the variable called P1M. All right, but this is definitely a correct solution too. All right, so now I'm going to run this code. It runs. I have all my variables right here in the workspace and I'm happy with my code. So I'm gonna copy all of this. Please remember, do not recopy anything that was already given in the script because that will lead to overwriting these variables. All right, so I'm just going to copy my own code, go here and paste this. Okay, I'm going to run the script again on MATLAB Grader and submit. All right, all tests passed and we are done with this question. Hi everyone, we are now starting with homework question 5, swapping numbers and relational operators. So before we start this question, I would like to draw your attention to the concept of swapping numbers. So we have received lots of questions about these during office hours and I want to make sure everyone understands how swapping numbers works. All right, so let's say I have this question. So I have x equals 3, y equals 4 and z equals 5. And what I need to do is swap. So x should contain the value of y should contain the value of z, and z should contain the value of x, right? So a lot of times students write the code in this way. They would say something like x equals y equals z, and z equals x. Now, although it looks like what has been asked, this code would not work. And why is that? Let's go step by step and try to see what happens when you do this. So it says x equals y. So x would have the value of y, which is 4. Let us do that. So I erase this and I say 4, right? Now it says y equals z. So this 5 would go into y. Okay. So now y equals z. And finally it says z equals x. Okay. So now z equals to this new value of x, which is 4. So I would erase this and I would say z equals 4. But this is not what we wanted. We wanted z to contain the value of x, which is 3. And now in this particular code, we've completely lost the value of 3. Therefore, what we need to do in questions like this is always introduce a temporary variable. So at the beginning of the question, I would say temp equals x. Now let's revert back to the original values of x, y, and z and see how this new new code would work out. Sorry. So again, I have 3, 4, and 5, right? And now I've said temp equals x. So there's a new variable created, which is temp. And this is equal to x, which is 3. Okay. And now I would do the exact same thing I did last time. So I would say x equals y equals z. And instead, in the last part, instead of z equals x, I would say z equals temp, which is actually equal to the original value of x. So here I would write temp. All right. And what would happen in this situation? So x would become y. So here x would become 4. Y would become 5. And unlike the last time where z was becoming 4, which was the new value of x, z is going to be equal to temp, which is the original value of x, right? So the concept of temporary variables is very important when it comes to swapping, and it must be used in every swap question. Okay, so now let's utilize this to solve our question 5. Okay, so you're in the lab and have tested the Mohs hardness of 4 mineral samples and assigned those values to the variables sample 1, sample 2, sample 3, and sample 4. So what I'm going to do is copy this script and paste it in my editor. Oh, before that, I should save my file. So I'm going to save, and I'm going to write homework 1, question 5, and I'm going to say swap. Save. All right. So now I have the snippet that has already been provided to me. Okay. However, your samples got mixed up after testing. The Mohs hardness of sample 1 was assigned to sample 3, 2 was assigned to sample 1, and so on and so forth. So a good way to approach this situation is, as we learned, to create temporary variables. I could use 2 temporary variables, but since I have multiple variables in this question, a good way to approach this would be to create multiple temporary variables. In that way, you would avoid confusion and will be able to solve this problem in a very easy and straightforward way. So what I'm going to do is I'm going to create 4 temporary variables and store each of the values that are given, so all of this, in those temporary variables. So I'm going to say TMP1 equals SMPL1, SMPL2, TMP3 equals SMPL3, and TMP4 equals SMPL4. All right. So these are my temporary variables. Okay, now I need to swap them. So swap. Oh. Sorry. Okay, so let's read through the question carefully again. My samples are mixed up. The Mohs hardness of sample 1 was assigned to SMPL3. So I need my SMPL1, which is the variable that should contain the value of Mohs hardness for sample 1. And what should this contain? So the hardness of sample was assigned to sample 3, which means this. So my SMPL1 should have the value of TMP3. Okay. 3, okay, no, sorry, I missed this. Yes, the Mohs hardness of sample 2 was assigned to SMPL1. So here I would write SMPL2. And the hardness of sample 2 was assigned to sample 1, which is now contained in TMP1. So this would be TMP1. Please note right here, if I had written something like SMPL2 equals SMPL1, this would be incorrect. And why would that be? Because SMPL1 does not equal to the number that was generated initially. SMPL1 now equals temp3, which was the value stored in sample 3, right? So this statement would be completely incorrect, which is why using these temporary variables is very important in these questions. Okay. So now I would say SMPL3. Oh, oops. Okay, so SMPL3. So sample 3 was assigned to SMPL4. So it's this, which is temp4. And 4 was assigned to SMPL2. So SMPL4 equals temp2. All right, so I have my swapped values and this will work for me. Do you see how creating multiple temporary variables has made it really easy for me to write the code and also cross-reference the question? So if I make a mistake here, it'll be really easy for me to go back to the question and check it. You can do this with lesser temporary variables too, but this makes your code really readable and easy to debug in case you've made an error. Okay, so now we have the next part of the question. Each sample has the correct Mohs hardness assigned to it, yes. If you want to figure out how many of your samples have the hardness over 5. So now what I need to do is I need to figure out if the new values of these samples is above 5. So what I am going to do is Mohs hardness over 5. I'm going to define a bunch of new variables. Oh, I think this does not have an apostrophe, yes. I'm going to assign a few variables. I'm going to call them LG1, LG2, LG3, and LG4. And this is going to contain if the sample 1 Mohs hardness is greater than 5. All right. So what kind of an output is this going to give me? This is going to give me a logical output. So if sample 1 is greater than 5, it's going to return a logical 1. And if it's not greater than 5, it's going to return a logical 0. And I'm going to do the same thing for all of them. So now what I have is 4 logical values telling me if sample 1, 2, 3, and 4 is harder than 5 or not, right? And now the outputs of this is logical 1 or 0. How can I use these logical values to determine how many of my samples have hardness over 5? Now, if you remember how typecasting works, is if I include a logical value in an arithmetic operation, then MATLAB implicitly converts the logical values into an arithmetic number. So if I were to add LG1, LG2, LG3, and LG4, I would automatically get which one of my samples has a hardness over 5, because the samples with a hardness over 5 would have a value of 1, so that would be added. And if it didn't have a hardness over 5, it would add 0, so nothing would be added, right? So what I'm going to do is total SMPLS equals LG1 plus LG2 plus LG3 plus LG4. And that's how I would solve how many of my rock samples have a Mohs hardness over 5. I don't have to typecast them myself, since MATLAB automatically implicitly typecasts all of them into arithmetic double values for me. Okay, and now I'm going to run this question. Okay, it runs properly. If I go to my workspace, I have all my numbers, which look good. And now I'm going to copy this and put this in my MATLAB Creator. And then we run it. Code ran without output and submit. All tests pass, perfect. Hello. We're finally on our last solution, homework 1, question 6, arithmetic, relational, and logical operators. I will start by naming my file. save, and I'm going to say homework 1, question 6, arithmetic, relational, logical, and saved. All right. So the first thing I'm going to do is read the question. So Chilman and the TAs are working on solving a question where they need to find the value of x from a given p. However, they had to refer to a list of values and unknowingly use 3 different lists for the variable p in their equation. Their p values could match with each other or be completely different. Kasturi used pk, Bianca used pb, and Chilman used pc, which have been provided to you. So I'm going to take a look at the code snippet. Yes, I have all 3 values of pk, pb, and pc. I'm going to take this and paste it in my MATLAB. So as I can see, pk, pb, and pc are randomly generated integer values ranging from -2 to 2. And this is the p value that each one of these people used. I have the equation provided to me, and let's look at part A. So check if both Kasturi and Bianca's p values match with Chilman's p. If both p values match Chilman's, assign true to a variable named case 1, else assign false to the variable. All right. So for part A, the variable I need is case 1. So I'm going to write case 1 and put the equal to sign. All right. And taking a look at the question again, so I need to check if both Kasturi and Bianca's p values match with Chilman's. Let's break this question into little segments. So the first condition I need to satisfy is if Kasturi's value matches with Chilman's. And how can I check for that? If you remember your relational operators, we have the equality, which checks if 2 numbers are equal to each other. So if I use this, I can check if Kasturi's p value matches Chilman's p value. So I'm going to write that down right here. Kasturi's p value is pk, so p underscore k equal to pc, which is the p value used by Chilman. Okay, what's the second condition? It is if Bianca's p values also match with Chilman's p values. How would I check that? In the exact same way. So I would also say pb double equals pc. And how would I join these 2 conditions? So my first condition is Kasturi's value matches with Chilman's. My second condition is Bianca's value matches with Chilman's. And I need to check if both of them match with Chilman's. So if you look at your logical operators, which one of these operators give me an answer of true when both conditions are true? That will be the AND operator. So I have true and false, which would give me false, and I have true and true, which would give me true, right? So I'm going to be using the AND operator to make sure that both their values match Chilman's. So here I'm going to write AND. All right, moving on to question 2. Check if either Kasturi's or Bianca's p value matches with Chilman's. If either or both p values matches, assign true to a variable named case 2. Else, if neither p value matches, assign false to case 2. Okay, so the variable for this particular segment is case 2. I'm going to write that. I'm going to put the equal to sign. Once again, I need to check if Kasturi's value matches Chilman's and Bianca's value matches Chilman's. So I'm going to write the exact 2 statements here. I'm going to write this is the first condition. This is the second condition. But how am I going to separate them? So here it asked if both of their values matched with Chilman's. So whereas in the second question, it checks if either value matches Chilman's. So if either or both values matches, assign true to the variable. Let me take a look at the logical operators, in which case, if either of the values are true, it's going to result in a true. And if both are true, it is also going to result in a true. And if I look through this table, I can see that happens in the case of OR, right? So when both are true, the resulting value is true. When one of them is true, the resulting value is also true. So OR is the statement I'm going to use. OR is the operator I'm going to use in this particular answer. All right, so OR. Perfect, so I'm done with part 2 too. Moving on to part 3. All right, So assuming that PC is the correct p-value, calculate the value of x and store in a variable named xc. Okay, so the variable I need to store my value in is xc. I'm going to write xc right here. And it has told me that assuming that PC is the correct p-value. I have been given the equation for x right here. So I'm going to try and replicate that. And when I'm using any of the p-values, I'm going to replace that p with PC because that is the correct p-value, right? Okay, so let's start writing. The first of my numbers in the numerator is a square root of absolute value of p. So I can write that as SQRT of ABS P. The absolute value function returns the absolute value of the variable within it, and the SQRT function returns the square root of the value within it. And the value within the square root function here is ABSP, which is exactly what this equation needs. All right, and now I multiply this whole thing by 100 times p plus 20. So due to operator precedence, this is the segment that is going to be executed first, and then it's going to add to the 20, which is okay according to my equation. This is my numerator, and now I'm going to divide the whole thing. So I'm going to put 2 brackets because the whole thing is my numerator, and divided by the denominator, which is p to the power -4. So how would I write p to the power -4? I'd write p, and then I would use this exponential, negative exponential 4, and that plus 5. All right, so this is my denominator. I'm going to write this. Another way I could have written this function, a better way actually, would be to split it into numerator and denominator. So I would write numerator equals, so let's look at the numerator again. So it's square root of absolute value of p. So it's SQRT ABS p, double bracket, and then I would multiply it by 100 times p plus 20. So this is just my numerator, and I'm going to define another variable called denom to define my denominator, which is p to the power -4 plus 5. So I'm going to write p to the power -4 plus 5, right? So this is my numerator, this is my denominator, and now I'm going to define xc. So I'm going to comment this because I'm introducing a new xc. xc equals nomi divided by denomi. All right. This is a better way to write this same statement, because when you're writing something like this with a lot of variables, with a lot of functions, it's very easy to make a mistake. Also, I completely made a mistake here. So I have used p-values in all of this equation while I was copying from this particular equation, right? But the question says that PC is the correct value. So how am I going to change that? And also, if I run this code right now, it's going to give me an error because there is no p-value. There is no p-value declared in this whole question. So I'm going to edit all the p-values and make them PCs. PC. Oh, no. PC. This is a comment. This is how you can write the XC expression, but this is a cleaner way to write this, and there's a lesser chance of making a mistake. So I'm going to change it here to PC, PC, PC. It's very important to proofread your problem while you write it to make sure that you don't make mistakes. And running it on MATLAB software is a great way to check your program, because if you run it on MATLAB Grader, there's a high chance you're submitting it and then you realize you've made a mistake. All right. So I'm going to run this. Okay, it's running and I have no errors right here, and I have all my values here in the workspace. Perfect. So I'm going to copy this code. Oops. I'm going to copy this code. Make sure that I'm not recopying the PK, PB, and PC values. All right, and then I'm going to run the script, click submit. All tests passed, perfect. Okay.